Are we live?
Cool.
Are we live? Is this
We
it
are
happening?
we
I think it
are
is.
live.
All right. Ben, you want to do the honors?
I will do the honors. Okay, guys. We have a substitute student today standing in for Benjamin Davey, aka Falcor. We have the other Ben at Scale. So I've got my notebook, I've got my pen. I am about ready to get educated on all things privacy. And who we have here with us today is Professor Sawyer, our head of developer success at Scale Labs, and our guest professor, Gaylord Warner, who's the PMM and ecosystem lead at Miden. You guys perhaps want to just give a quick introduction of yourselves, and then we can dive into what we're going to talk about today.
Absolutely. Hello, everybody. It has been about a week now since we've last seen you, so thanks for coming back. For those of you that don't know me, my name is Sawyer. As Ben mentioned, I run Scale's developer success team, so I work with our partners, our enterprises, et cetera, to help them build on Scale. As well as work across all of our, experimental stuff that we're doing right now with, agents, X402, privacy, all that good stuff. So great to be here. We'll talk more about Scale in a little bit, and I'll pass it over to you, Gaylord.
Thanks, Sawyer. So yeah, first time for me. Thanks, guys, for having me. It's great to be here. And on my side, I'm working with Miden. So you might know it as the Edge blockchain. It's a novel project, very much focused on privacy, a blockchain with a novel architecture based on the actor model with some ZK sprinkled on it. We'll get into it, I'm sure. On my side at Miden, I'm product marketing manager, also a lot working with the ecosystem as a whole, with these teams we call pioneers. So people building, actually trying to build with Miden and the novel concept it comes with. In the past, I was a long time ago in a previous life, I was a developer in TradFi, so I come from the engineering side. And in my my previous role was with ZK Hack, a community-led project that's all about educating people about ZK and onboarding them in this great industry. So always happy to talk about ZK and trying to teach people, even though there are people better than me, but I still know a couple things.
All good. Love it. It's gonna be. I'm a little bit of a student today as well, because that is definitely an area that I wish I knew more about. I think enough about privacy and encryption and everything as probably your average engineer, but excited to learn more about it. But Ben, over to you. You're running the show today.
Yes. Privacy. You've heard it now a few different times mentioned, so that is what we're going to be talking about today. I think we've all seen that privacy has evolved or is amidst of evolving from kind of a niche feature into a core layer of blockchain infrastructure. ZK technology to everybody's wanting to make sure that the trust is there, user protection is there, and that as AI continues and agentic usage continues to explode on chain, that there's privacy involved in that as well. So kind of what we're going to talk about today, if we're breaking down this lecture into a couple different parts, we're going to learn about why privacy matters on chain, dive into how privacy works and the technology behind it, and then also kind of wrap things up, maybe with a nice little bow, probably couple loose ends here and there, but what privacy means for builders in the future of the agentic web. So let's kick off with why privacy matters on chain. I like to think about it personally in that I love blockchain for the immutability. I love blockchain for the fact that the transparency is there, but at the same point in time, it's like you don't need to see everything. Everybody a lot of people like sausage, but not everybody wants to know how the sausage is made. I think the same can be said with a lot of stuff on blockchain. Everybody wants to see the end result. You want to make sure that it's there, that it's immutable, that it took place. But I don't want to know everything, or I don't want everybody to know everything that's involved with the parties that are transacting. So maybe, I'll toss this first question out there, and the two of you can decide who wants to take it. But why is privacy such a central topic again, right? We saw ZK pop up, and then it kind of lulled down for a little bit, fell out of the narrative, and now privacy is kind of coming back. So why is privacy such a central topic in the blockchain space right now?
Yeah, I think, Ben, just to kind of kick things off, I think the reality is that there's levels of privacy expectation in society. And I think despite, innovation in technology, I don't think people want to take a step backward. We've been using the term, or phrase, I guess, commercial confidentiality or confidentially commercial a lot with what we're building with, Byte protocol and trusted execution environments, because we kind of look at it from, I think, this stance of, I have a level of expectation for privacy with, for example, my financial side of my life, right? I go to, buy a cup of coffee. I go to the grocery store. I pay. I pay people. I buy things, whatever, right? Like I'm doing all this stuff. I'm paying on Amazon, whatever, right? And all of these companies know just enough to process the payment. They know just enough to make sure that it can be executed, but they can't go all the way down and trace me back to my bank account. They don't know what's in my bank account. They don't know how much is in my bank account. They don't see the inbounds and the outbounds from my bank account. All they see is, right, the credit card payment or the cash that I'm giving them or the debit card payment or whatever it is. And so that's that kind of level of, commercial confidentiality that I think society tends to expect at this point, where it's like the people around us, the businesses and the entities we're interacting with daily can't see in what we're doing, but the government or the bank, obviously, right, can see that information. And so I think when it comes to why privacy matters on chain, we're at the point where we are seeing the on-chain adoption occur, but we need to figure out how to get to that same level of what people expect. Because otherwise, why would they come on chain? Why would they move all their money on chain if now everyone can see what they're doing, how they're getting paid, stuff like that? So I think that's why privacy matters on chain for me. Gaylord, any thoughts on that?
Yeah, I mean, I do agree with everything you say. I would be a bit even like cynical, because everything you say is true, but it also was true like 3 years ago, right? And I think that it's hard to talk about why it's becoming a central topic, on chain without talking about Tornado Cash. So the legal issue that these guys face, developers being sued for developing open source technology, that was pretty dramatic. So I really want to stress and provide my support to them, because it also put the whole industry in a weird area where people were afraid to be sued as developers of software, which makes no sense, by the way. But I feel like the clarification, or at least the direction the trial is going with, even though it's not completely wrapped up, but the direction it was taking helped people to actually refocus, I would say, on the privacy topic, even though some teams, I mean, including ours, but some other teams as well, kept the focus on that. Because yes, and then I will reiterate what you said, I feel like, the adoption we want for the blockchain we know and love, it cannot happen without privacy. Otherwise, we're really talking about this type of weird dystopian world where anyone can see your balance and know the money. And I mean, one of the co-founder of Ledger, got his finger cut. That's, I mean, these are real risks. I mean, I'm laughing. It's really not funny actually, because the people are at risk, like people's life are at risk because of the transparency. Again, it doesn't mean like it needs to go away, but this way of being able to make it flexible, have this kind of privacy that's programmable, I think is a very powerful primitive. And that's what we are working on at Maiden with some technical choices. There are many ways to achieve that, and we will get into it. But I feel like, yeah, people came to realize that privacy is a must for adoption. And now we're in technical, legal, the good context for it to be actually worked on. And we are seeing these tools now, coming to life finally.
Definitely. And I want to call out something that I think is really relevant that you said, which is programmable privacy. right? I think that is something that when we think about blockchain, right, there are use cases where we want things to be public, right? Maybe it's donations, maybe it's government payments, right? There's all sorts of reasons for things to be public and for things to be traceable and auditable and things like that that are, don't have to be private. And I think what's cool about what you guys are building, what we're building, and what so many other teams are building within blockchain is that it is something that's programmable, right? It's not something where we're trying to hide everything by default. What we're trying to do is we're trying to give real businesses and real human beings the ability to have privacy where it matters, while maintaining that level, ideally, as much as we can, of compliance, while so many larger corporations go to bat with the government entities around the world and do try to improve things and make allow us to have this flexibility to build software and to your point, ideally not wind up being
in jail.
Attacked for building software that's trying to accomplish a goal.
Yeah.
So I really like that call out and agree. We'll get a little bit deeper here into the ins and outs of how privacy actually works shortly.
Yeah, and I think the important thing to think about there, right, is yes, there's the security risks for individuals that we want to be aware of and we want to protect, but also, as we look for adoption, right, like the larger corporations, these larger entities, as they're bringing their capital, as they're bringing more on chain, they're not going to want to have all of that exposed either. Like if they're used to having one type of environment, they're not going to give that up for blockchain. We all love blockchain. We all think blockchain is where things are headed, and technology wins at the end of the day, in my opinion. But these multi-billion-dollar companies aren't going to sacrifice privacy for the technology. They're going to stick with, the same reason a lot of these use Microsoft Teams or some of these outdated modes of communication, because it works, it's safe, it's secure, they're not taking risk. They're very risk off. Whereas we in this industry tend to be very risk on. So privacy is massive. I have a question now. I know we talked about a little bit about some of the real world risks, but let's talk a little bit more maybe about kind of like AI and automation and agentic behavior, and how does privacy enable these new forms of automation and agentic behavior that we're seeing pop up and that are massively taking over the world. I mean, I'm here in Silicon Valley, and the amount of billboards around AI companies is everywhere. Every bus, every sign alongside the highway, every building has something for some AI agentic trader, agentic system that's doing something that enables or automates a part of your life. So how can privacy, enable these new forms of automation and agentic behavior where systems can act and transact independently?
I'm gonna let Gaylor go first in this one, but I just want to call out that maybe not my favorite. One of my favorite parts about visiting San Francisco is the billboards. I love them. I love how people just have like tech billboards on their rooftops. It's like it's the coolest thing ever. Amazing place, but I'm gonna let Gaylor go first here.
It helps offset the rent. So if you put a billboard up, you rent out space of your apartment to these AI companies for rent. So.
Yeah, thanks for the nice tips. I'll keep that in mind if I want to settle in San Francisco. So I'm actually not an AI expert, but I would say that what is privacy? It's just a way to manage the flow of information. So what should someone else or some other structure know about yourself? And it depends. Depending on the situation, you don't need the same flow of information. If you're at the doctor, it's not the same than if you're buying a coffee, than if you are buying a house, etc. And with AI, you have like basically agents taking over this flow of information to act on something and make decision instead of you. So again, I feel like we're back to this real world discussion. Like if you're in the real world, when you just withdrawing money at the ATM, You don't want the ATM to shout, there is like 20K on the account. I mean, nobody would want that. Nobody would go to that ATM, right? But at the same time, if the government has, some ways of displaying what they do with the taxpayer money, maybe actually in that case that's good. So again, depending on the situation, the flow of information has to be managed differently, and AI is just an application of that concept. So for AI agents, if you are not able to protect your privacy for the flow of information you need depending on your use case, then you cannot use agents, right? And you're stuck from the start. So again, for me, the privacy, again, the fact that you would be able to define which level of privacy you need is kind of a must to really use AI agents for all the use case you can think of. Like, again, medical records are a good example, but financial operations also another good one. And depending on what you do, you need to be able to have the level of privacy you need to give away your information to some AI agent.
Love it. I don't think I could have said that even close to as cleanly and concisely. I fully agree with you there, right? At the end of the day, privacy is functionally the equivalent of our like digital data protection at this point, right? Like if you have it, your data is protected in some way, shape, or form. If you don't have it, it's not. Obviously, there's more to protection of data than that, as far as you get down into encryption and access controls and all that good stuff. But at a very high level, without privacy, we do lack. Well, we lack the basics that protect us, right? And I think for me, I think two sides to where privacy is most relevant for AI. I think in the world of just pure AI, it's the ability to have information shared and consumed securely while you're asking and delegating actions, right? I think a really good kind of thing to think about there would be most companies, and even, like consumer behavior at this point, we just delegate to services, right? Like that is the consumer lifestyle now, right? Everything you do on your phone, you pick up and you use some other person's application where they control the data. And now as more and more people are using AI, they're then further delegating that out to LLM providers like OpenAI, or, these like, to Ben's point, you've got all these companies that are building, specialized agents for things, and you have no idea what these people are doing with your data. And so I think there's this really interesting world that is actually being explored on chain. It's a standard called trustless agents. The actual EIP is 8004 if you're into more like Ethereum technical stuff. And they're working to figure out how we can allow agents to, share information securely and trust each other to do some arbitrary action. And I think this is a huge part of it, right? Is how can you actually do that if the information is not, private when they're sharing it back and forth? So I think that's kind of like one side. And I think the other is almost more just like raw data storage, which sounds maybe really bland, but data is like digital gold, right? The more data you have, the more you can do. Everyone wants it, can't get enough of it. We all want to generate it. And I think there's a big question of when we're building programmable privacy, it's much, I guess like the way I would phrase this, and Gaylord, tell me if this makes sense to you as someone who you guys are much more developer, we'll kind of call it developer friendly because you're not EVM, right? You can build in like TypeScript and stuff. So
yep.
A little bit easier for developers to action on. I think there's this interesting world where you have data movement and data sharing versus data at rest. And the privacy for the two are very different, right? Because having data that just sits there and is private and is used by a singular application is functionally a lot easier, right? Having data that has to then be taken and somehow like decrypted or shared privately and then known later is very complicated. And so I think that's ultimately for me where ZK starts to get really interesting, right? Because ZK allows us to start to solve that problem of we have this data, we need to somehow consume it elsewhere, but maybe we don't even need to actually share the data, right? Maybe we can just share a proof that the data exists, or in some way, right? Am I kind of thinking about that the right way?
Yeah, you are. But the funny part is also I can see that you're still a bit confused, and that's the funny part with ZK. It is very powerful, but it's kind of a new paradigm. So you have to change your way of thinking. And exactly as you said, in the traditional way of thinking, it's like, I have some data, I need to show it to someone for this someone to do something with my data. Well, with ZK, it's not the case anymore. It's more like they ask a question about something and I'm proving the thing on my side, and then I just send some gibberish that actually is not gibberish, is a proof that actually can cryptography certify that the answer to the question is yes or no. So you need to think a different way. And as you said, it has an impact on the application developers, because you have to build your application very differently from what you would have done in the classic Web2 world. So yeah, we can't get into that.
Yeah.
How you use ZK for privacy, but it's tricky a bit.
Yeah, for sure. So just to wrap that up on the agent front, the reason I think it's so interesting is I've been having a lot of discussions with developers building agentic applications. A lot of teams building like facilitators for X402, stuff like that. And I think a big question that always comes later for people is compliance and regulation and all that good stuff. And I think a really interesting thing that I'm kind of imagining that I think ZK will be a huge help with is his ability to prove identity without needing to share that information, right? And so a good example, and I know I feel like something that the ZK world has been chasing for a long time is like provable KYC, right, or KYB, right? Being able to prove that I'm a known entity, I'm a good actor, I'm not, a bad actor or malicious, without having to actually give my social security number, my driver's license, my passport, whatever it may be. And I feel like for agents, that's a really interesting potential overlap with ZK, right? Being able to say, I actually own this agent, and I can like delegate my identity to it so that it can prove that it's representing a good actor, not a bad actor. So that's kind of where I was going with that. But yeah, let's jump into the nitty gritty. I'm excited to learn more about ZK here.
Yeah, I think that's something, I'd be curious about as well. I mean, the ZK, getting into the weeds with it, Gaylor, maybe you could tell us a little bit more, because Scale has its byte protocol, which fully encrypts the transaction from the moment it starts until the moment it's finalized. Now, how does that, and sorry, maybe you could also provide some color on this for those that are listening as well as me, but like, what is the difference between byte and ZK technology?
Sorry, byte? What is byte?
Let's start with some color. So byte stands for blockchain integrated threshold encryption. For those of you that are new to Scale, I should probably give my 20-second Scale intro shill that I'm supposed to do whenever I'm representing. Scale is a network of blockchains. Every blockchain today has zero gas fees, EVM compatible, instant finality, super fast, and all these chains are interoperable. So essentially, it's a network of blockchains that can scale infinitely. That's what Scale is. Now, what makes Scale so interesting from a design perspective, and why this is relevant to today's conversation of privacy, ZK, FHE, and Ts, is Scale chains are basically built on top of actual nodes. So it's not an L2, it's not a roll-up, it's actually an actual blockchain with validators. Inside these validator nodes, each validator runs what's called a T, or a trusted execution environment. Now, Ts are really interesting because Ts by themselves are actually not that secure. They're good for processing data, but there's many vulnerabilities that are very well known around single access and physical access to Ts. So what our genius team of mathematicians, physicists, and cryptographers at Scale has done is they have taken what is called BLS threshold cryptography, which is this world of basically where we have many actors that come together to do something. And they've created a distributed scheme that uses many Ts to create a shared public key and private key shares that can be used to encrypt and decrypt data. And so what byte protocol does is, instead of just having a single entity encrypt the transaction that is then decrypted later, which would be not so secure using Ts, because anyone with physical access to the machine would be able to break this. What we do is we have all of these entities in the network have that public key that's shared. The data is encrypted with the public key, and then the supermajority, aka like greater than 2/3. So if we've got 100 validators, 67 of them have to provide a decryption share of the data. Once 67 or more provide that decryption share, we can actually decrypt the data. And so that is essentially what Byte protocol is. It allows us to run encrypted transactions in encrypted mempool directly within consensus of an EVM blockchain. Now over to the world of ZK, as we've started to kind of get educated on, we don't actually have to show the data. So I think that's where we're going to start to see that big split is different programmable types of privacy for different situations. One may be a little bit better for something that needs to stay private until execution, like Byte. But now if we want to do something that stays fully private end to end and we never have to show the data, I think that's where we're going to start to get into FHE, which we can technically do with Byte, and more specifically here ZK. So I'm going to pass it over to you, Gaylord, for our educate us on ZK.
I mean, first, you kind of nailed it in saying that don't count on me to say, ZK is better than this or that, because it's not the case. It's just different cryptographic techniques for different use cases. And that's what you said, and that's very true. So yeah, FHE maybe is more in the realm of what you described, where it's like you encrypt something and you have another server that can do operation on this encrypted data and then sending back for the users to decrypt, and then the results is legit, which is also quite magical, to be honest. And it's a hard problem. Nowadays, you always have like some performance limitation, which makes it good for some use cases and not as good for others. Okay, but let's focus on ZK for a minute. So just to remind people, ZK stands for zero knowledge. Zero knowledge because the idea of it is you would be able to prove a statement without showing to the person verifying your proof any data related to the statement. So the usual example is this, the passport example. You talked about identity earlier. So how would that work for a passport, for instance? So the general problem would be prove to me that you're more than 18, or 21 in your case, because you're in the US. So more than 21. The user, I'm the guy with the passport. I would be able on my device locally, so it doesn't get out of my computer or my phone, to get the data from the passport on my computer. So of course it's mine, it's fine. I would generate a proof that I am over 21. So that's based on my birth date. That's on the passport. The passport itself is cryptographically signed by my government. So obviously from my accent, French government for me, but US would work as well. You verify that it's a legit document. That's what's written on the document is a date that proves that I'm older than 21. And that's just it. It's like a Boolean if you're a developer. It's just true or false. And then I would send the proof to you. And the proof is really just a long string. You put that into this algorithm called the verifier. And then it's just verified or it's not. So if it is verified, this is the cryptographic, so mathematical proof that the data on my passport is valid. So my date of birth is like, before 21 years old, 20 years ago. And also it would, otherwise it's useless. It would also verify that the passport is legit. So again, all of these things can be done. And it's always in this prover verifier situation. So it's really two people or two systems interacting with each other. So again, as you can see, it is a bit different from this encryption mechanism where you encrypt some data, you send it somewhere, maybe you retrieve it, you decrypt it. Here, there is no data transmission. You see in the ZK paradigm, even if the encryption algorithm is broken in like 10 years or 20 years, it doesn't matter. That there was no information in the first place to be transmitted. So you can't leak data because there is no data traveling in the pipes. So that's really the superpower of ZK, which makes it good for some use cases, but maybe not everything either.
That was the best way to explain ZK technology that I've ever heard. Thank you. I think I don't know how you broke that down in a way that, yes, me as the student today actually finally understands ZK technology. So kudos for that. We got the right person on the show today, Sawyer. That was Gaylord. Thank you for that. Yeah, I don't really have much to add other than that was awesome. So I guess to dive into, another question, that we have here is, I guess we talked a little bit about the technology, the core privacy technologies of ZKs, FHEs, and Ts. The purpose and what is the purpose of these different types, right? Like we talked a little bit about byte is like very short term. Scale and Fair have byte technology, which is like, hey, it's on the, at least this iteration of byte is for the transaction. It's for, if you think about an agent or wanting to have an edge, like maintaining that edge. ZK is more overall for privacy in terms of information and ensuring that information is secure, it's safe, that nobody else has access to it, right? Like the proof is verified and then you're good to go. How about when we look at kind of like the FHEs and the Ts, and maybe you guys covered this already and I just missed it because I was overwhelmed by Gaylord's description of everything, but their purpose, their design of things, like I guess if we're talking about these 4 different things, how do all of the different pieces of the puzzle fit together? How are they separate? The purposes drastically differ or the same, or where's the overlap amongst all of these?
Yeah, I think before we answer that, let's quickly I'm going to give my definition of fully homomorphic encryption because I do think it's relevant to this conversation. So you've got basically the core of you've got single use encryption essentially, which is what byte is, right? It's like essentially it's like temporary encryption. Okay. Then you've got ZK, which is proving that something exists or can be done or is correct. I think that's maybe the best term. Proving something is correct or not correct based on data that you don't actually show, right? Then you have this kind of like, I think kind of up there with ZK, you have this other thing called FHE or fully homomorphic encryption. And it is arguably, I think, easier to understand than ZK, but like how it actually works is, I'm not going to try to give a good definition. That would be a Stan job, or maybe Gaylord would be a better one. But essentially, it allows us to do computation on encrypted data. So imagine we have, we'll go back to this idea of a passport. We want to essentially have call it every time you visit a country, right? We want to update your passport record in that country without actually pulling the passport. But we know that there is some record that says how many times you visited the country, essentially, right? Pretty simple. We don't want to decrypt the data. We don't want to look at the passport information. We just want to say we have this ID that corresponds, and we essentially want to update the data to show that you've been to this country again and again and again. And so we're making that change without actually decrypting the information. So we're updating encrypted data. Kind of a terrible example. I'll come up with a better one. I think maybe the better ones are banking. They just take longer to explain, like private balances and stuff. That actually is a way better example. We'll talk about that.
Yeah, the passport here is a bit far.
Yeah,
but
I'll go with banking.
It's definitely. I mean, actually, I wouldn't use banking. I would use like pharmaceuticals or stuff like that, because the FHE will be useful again. Yeah, definitely, as you said, to work on encrypted data. So you have a very strong privacy angle to that, but it's useful when you cannot on your side process, run the execution because it's too much, servers, too much power. So I feel like it's useful when you want to keep privacy, but have like some big ass server doing the hard work. So again,
yes.
I'm always thinking of these pharmaceuticals, complicated models. I don't know anything about this, so maybe that's why I'm overcomplicating it. But in pharmaceutical, I feel like there is like some personal data, and you would want to encrypt these, and then there is like some fancy complicated computation for which you need a server. So that's kind of the example I usually have in mind when I want to see why FHE is useful. Because you would encrypt stuff and then do something and then sending back to the people with the key. There is also, definitely in banking with this idea of public and private shared state, but it's a bit more complicated. But again, there is the idea of encrypting, doing something and sending back an encrypted operation, and then
definitely. Yeah, I think and maybe Ben, you'll like this. I think if we want to put all these in play, right? Because the question, your next question is well, when do we use each of these, right? And I think the easiest way is, let's look at an example where you actually would, as a business, I think, use all of these to solve different problems within the flow. And so I am going to use banking because now that I said it, I have the thought in my head, so I'm going to go for it. And if it makes no sense, that's okay. Sometimes my words are just, well, not the greatest, but my idea is relatively simple. You have a bank, right? So Ben has $1 million. I've got $1 million. Gaylord has $1 million. But nobody actually knows that we have $1 million. So forget that I told you that. Nobody knows how much money we have because it's in a bank, right? It's private. When it's in the bank, it is fully encrypted, right? So it's using that fully homomorphic encryption behind the scenes to actually update the balances. So if I send some amount of money to Ben, that action, that change to the balance, right? The change to each of our balances is done on the encrypted data, right? That's kind of your fully homomorphic encryption. So we're doing these actions, we're doing the addition and the subtraction on top of encrypted data. It's never decrypted for the public to see, which is kind of cool, right? So I think that's kind of your FHE piece kind of at the base level. Then the next question is, well, I want to send an amount to Gaylord. Actually, let's go back. I don't want to send an amount. One of us is going to send some amount to the other one, but we don't know who is going to send and how much they're going to send. It's just going to happen. That's Byte protocol for you, right? So someone's going to send some money, but the balance is encrypted and who it's going to is encrypted, right? And because it's FHE behind the scenes, when the actual balances change, we can't see that either, right? So Gaylord sent to Ben, Ben sent to me, I sent to Gaylord, I sent to Ben, Ben sent to Gaylord. Who knows? Someone sent some money somewhere. That's Byte. When the balance has changed, that's FHE. Then this is where it gets really fun. Ben and I, about 40 minutes ago, we're talking about how expensive houses are and how much money you need to get a house. It's really painful how much money you need. But the problem is when you want to go and buy a house, if you've ever tried to buy a house, they ask you for all this information. They want to know your life story. They want to know everything about you. They want to know how much money's in your bank account. They want to know all this information. But the reality is they don't actually need to know the information. They just need proof that you can afford the house in countries where there's credit, that your credit's good enough, and that you're a known actor, right? They need all this information. And so what do we use ZK for? We use ZK to prove that data in the bank that has our balances is actually big enough to afford the house that we want to buy. Prove that the income coming in monthly is enough to cover the mortgage, the note on the home. We prove that, we prove our identity to the lender, to the real estate agent, to the seller, et cetera. So I think that's kind of my end-to-end example of all these technologies being used by like a full flow where we make money, we spend money, we pay, we buy things, whatever, but all that data stays private, which is, well, if we live in the real world outside of crypto, that's pretty much how it works, minus the ZK piece. We don't have that yet. I'm excited for the day when that happens because, well, yeah, it's definitely be a big plus.
Yeah, the ZK part, actually, we talked mostly about privacy for now, but funnily enough, originally, the reason why so much money came into ZK research is actually not the privacy part. It's more like the scalability or the compression part. So zero knowledge is one of the characteristics of these cryptographic techniques, but another one is succinctness, making stuff smaller. So you can prove a big thing, and instead of, like for blockchain, for instance, instead of having to re-execute all the transactions once someone, has run them and organized the block, they could actually create a proof that they've done something, and then anyone else could verify that they have done that without re-executing everything. You could verify in a shorter time that it would take you to re-execute everything. So this is more the verifiability property of use case for ZK here, which is what ZK rollups are. Most ZK rollups, except Maiden, of course, but most ZK rollups are not zero knowledge per se. They're not about privacy. They're about efficiency and being cheaper. So that's an angle that's interesting, because in your example with FHE, there is kind of a trust component still on the server. So I encrypt my data, I give it to the server for them to do some operation, and then they send me back the encrypted. So yes, it's private, but how do I know for sure that the operation they've done is actually what I expect? I cannot. unless I mix it up with, well, ZK, but not the private ZK, the succinct ZK or verifiable ZK, which would allow it to do some ZK FHE. And well, the performance are terrible, obviously, as you can guess, but that's kind of the only way where you can not only encrypt your data, so keep your privacy, but also be sure that the server to which you've been sending your data has been doing, what it's claiming it's been doing. So it's it's an important piece of ZK because again, that's how it came up in blockchain world. And nowadays we're using the privacy side of zero knowledge proof, but technically speaking, the succinctness of the proof and the verifiability property is actually a very important one, if not more important originally.
Definitely. I think there's two pieces I want to pull out of that I want to expand on. I think the first is on the FAT side. That is actually why with Scale and with Fair and with Byte, we don't call it. We're not just doing FHE. We're not just doing fully homomorphic encryption. We're doing threshold fully homomorphic encryption. So the interesting part there is Ethereum and all these other blockchains that are proof of stake have brought this new paradigm to the world, which shows that economic collateral can be used to create good actors, essentially, right? Like that functionally is what proof of stake is we put up collateral to make more money, and in return we have to do good things, right? And if we don't, we're gonna get financially penalized. And so it's interesting about Byte protocol is our fully homomorphic encryption is actually based on this threshold cryptography. And so it isn't just we're giving it to one server, right? If, for example, like when you give something to, like Unichain, right? Unichain is running inside a T. If they do fully homomorphic encryption, it's kind of irrelevant because they're the single actor, right? It doesn't you just have to trust them. Whereas when you are using a blockchain with 4 nodes, 16 nodes, 100 nodes, 1,000 nodes, right? And they're doing this threshold cryptography on top of the fully homomorphic encryption, you start to get, I think, an interesting paradigm that I think is a potential counter to what you're saying in terms of how do we trust what's going on. And I do think it's just a different trust assumption, right?
Yeah, I mean, you're very right to say that the T's actually are bringing this verifiability property I was talking about.
Right.
It works. So for this use case, T's also work like ZK.
Yes.
Basically, everything I've said about ZK actually work for T's as well in that setup. So yeah, it makes total sense.
Yes. The other part that's really cool is, so I actually did, I think I spoke about this last week too, but it was such a good experience that I'm going to talk about it again. I did this workshop with this group called Sparsity like 2 weeks ago. They're a ZK team. The team's a bunch of really, really, really smart people, way smarter than me. I'm not a mathematician in any way, shape, or form. And what I got to do is I got to go through this like flow with them where they gave me a Nitro Enclave T on AWS, and I actually deployed a verifiable agent into this T, and then it was using succinct to create a proof, which succinct is like, how do we describe it? It's a network, right? It's
what we call a ZK VM. So it's like a computer that, while executing, creates a proof of the execution. Kind of what I was explaining before.
Beautiful, well worded. And to be clear, that is not a ZK EVM, right? Those are two different things.
Yeah,
ZK EVM is like a roll up that's pushing ZK proofs. This is actually just it's in charge of literally creating proofs, right?
Yeah, it's a verifiable computer. That's what it is.
Love it. Verifiable computer. I'm getting that tattooed on my forehead. So basically what I did in this workshop was I created this trustless agent. I used the Nitro Enclave to generate information. I then went to succinct and created a verifiable proof. And then I put that proof on chain. And what it allows it to do is it now allows the output from the agent to be verifiable, because the outputs from the agent are now all signed. They're done inside of the trusted execution environment. And they're basically, if you put in the same input, you can always verify the output essentially, which is really, really cool. And I think one thing you kind of mentioned that I thought was really interesting is when you think about this compression, right? It's actually something that, from my understanding, it helps blockchain scale, but it also helps us bring things on chain that today just can't come on chain normally, right? And what's really cool about that is it actually is a benefit to something like byte protocol as well. Because for those of you that are not aware, one of the biggest limitations to threshold cryptography, as well as ZK, is they're all really kind of slow. They require a lot of compute to be fast, right? In ZK, to generate the proof is very expensive and slow. In trusted execution environments and threshold cryptography, it's the threshold decryption part that's really slow. Encryption is really fast. Decryption is computationally expensive, and the more key shares you have, the more expensive it gets. So it literally gets the bigger you grow, the more expensive it gets. And so what's really interesting is I actually think there's a world where we combine these two things and we can do more byte protected transactions by doing some of this compute off chain and then having the settlement on chain occur fully encrypted end to end, if that makes sense, right? So you're doing transactions off chain, right? You're like, for example, I'm sending a bunch of transactions to send you guys money. We had a pizza party. I'm paying out for the pizza and the wings and all that good stuff and the beer. And we had a huge pizza party. There was like 10,000 people. Someone go try to put 10,000 transfers on a blockchain right now. Guarantee you most of the blockchains out there will just crash, or it'll cost you like $10,000 in gas fees, except Scale. So come use Scale. It's my second show of the day. Thank you very much. But you want to send 10,000 transactions. So what do? You can actually create these off chain, right? You can push them through the ZK verification on chain. And then even when they go on chain and are actually completed, the state changes would still be fully encrypted because they're encrypted with byte. I'm not a ZK expert, so Gaylord, tell me, am I kind of thinking about that right based on your knowledge of byte?
I mean, you are, and you kind of described how a ZK EVM works. I mean, that's what it is, right? You do like transaction on the layer 2, and it's having its own life, and then it's batching all this transaction into one, and this batch of transaction is then verified on Ethereum. So, again, you added some bytes on top of it, but the idea is very much the same, right?
What if we don't want to roll up though, I guess is the question, right? So like, what if I've got a smart contract on a Scale chain. It's an ERC20 and I want to send you $10, but I don't want that to be public. I want it encrypted with byte. Can I submit that through a ZK pattern where there's like a verifier smart contract on chain and the actual execution is done off chain? Does that make sense?
Yeah, I think it would. I mean, I don't know exactly how Scale is designed, but conceptually speaking, yes, it's again kind of as you said, you have the action you take off chain, and then if you're able to generate a cryptographic proof of everything you're doing, so for instance via this ZKVM, so the verifiable computer, then it's all about whether your blockchain has a way to verify this proof, right? And that's what's done in a smart contract on Ethereum. So that's what there are like some specific proof that needs to be small enough for it to be not too expensive, even though it's still expensive. So that's how it works. So again, the answer to your question is yes, even though there are like some implementation details or challenges, but technically speaking, yes, that's completely
very cool.
Great. Well, guys, you lost me for a little bit there, but it sounded like the two of you were having a lot of fun, and I hope everybody paying attention was having a lot of fun. I was enjoying it. I wasn't understanding all of it, but I was certainly enjoying it. We have but 10 minutes left, unless we want to hold class a little long, which is up to our two professors on their availability here. But I would be remiss if I didn't bring up X402. So how does this growing privacy stack that we've been talking about, that we've been discussing and diving into technically, how does it make it possible for agentic systems or X402 style payments to operate securely, autonomously, and safely? So X402 is, I think, the hot topic right now, at least in the privacy circles, at least in everything other than meme world. And so
even a little bit in that.
Even a little bit in the world, but, we don't.
I mean, I've just read a little bit about it, so I would be a bit general probably, but I feel like, all this, the privacy stack in general, or X402, which at the end of the day is kind of a standard, right? A framework for payments to happen on the internet. It's kind of a safeguard, just the way you make these AI agents usable in the world. So I was actually thinking of that metaphor as you were speaking earlier, Sawyer, but I see kind of AI as this, super mega powerful superhero, the kind of almost the bad one, like Omni-Man in Invincible or Homelander in The Boys, or something it's too much. If you leave it by itself, it's too much. You need a way to, have a framework, have some rail safeguards, have a way to make it usable for the world without putting your own life, the life of people using it, in danger. And that's where, privacy comes into play. For instance, you need privacy for the AI agents not to have access to all your data, medical records, financial records, etc. You need a way to control that. And X402 is a bit different, is also a way for different agents to actually talk together and still being able to use money to do things. And well, maybe it's suddenly a spoiler, you need money to do things, right? But an agent cannot open a bank account in the real world, and that's like now the superpower of cryptocurrency in general. This is money that's usable by AI agents. So again, you have to kind of find a way to make all these great things, super powerful things, work together without, let them kill you. And these are the point of the privacy stack, the X402, and any kind of standardized way of this technology to work together, basically. So that's how I see X402, this HTTP protocol. But yeah, happy to hear a bit about what you think, Sawyer.
I definitely think we're mostly on the same train of thought there, right? I think for those of you listening that are not familiar with X402, you've been living under a rock for the last 3 weeks or so. Technically the last 6 months, but really the last 3 weeks, maybe even the last week. X402 is a open protocol created by Coinbase, being kind of fostered in by Coinbase and now Cloudflare via the X402 Foundation. Very simply, it is designed to enable internet native payments. Technically, if we want to get a little bit nerdy here, if you go on your website, or you go on, whatever phone website, whenever you call a website or a web server or a web page, it sends back information and some status code, generally HTTP 200, which means okay, like it's good. HTTP 402 means payment required, and that is why it's called X402. So for those of you that are trying to figure out why where 402 came from, that's exactly why. There's the status code called 402, which means payment required. If you want to access that resource, web server, web page, agent call, MCP server, whatever it is, you need to pay for that resource. And what's so cool about X402 is it basically standardizes what those payments look like, right? So if you're running an API, which is essentially a back-end server for supplying information, if you're running what's called an MCP server, which is a model context protocol server, it's something that makes it easier for agents to access tools and information. If you're running a website, if you're doing anything that is web connected, right, and you want to sell that resource, you can now do it in a way that's standardized. It makes it very easy for people to pay you. Now, today, 99.9% of that is being done publicly via stablecoins and cryptocurrency through blockchains like Base and Solana, as well as through tokens primarily like USDC from Circle. Now, what X402 actually enables, though, is us to think a little bit more broadly around this can be done using credit cards. It can be done using bank accounts. It can be done using ACH. It can be done using deferred credit systems and private accounts and all this cool stuff. And it also has these things called extensions coming in V2, which are going to allow us to create things like reputation around it, which could be, using ERC 8004, can allow us to do private data sharing, maybe using ZK or Byte or fully homomorphic encryption, sorry. And the end result of that is we get this protocol, which, to Gaylord's point, allows us to, at the end of the day, make internet payments and do things. And primarily in this world of growing AI, it allows us to start to build really unique systems. And so coming kind of full circle back to, well, how does privacy fit in here? We need access to private data. We need to prove things, ideally, without giving them away. we need to be prepared for a world where instead of me transacting on chain once a day, a couple times a day, once a week, once a month, my agent might be transacting hundreds of times a minute. Who knows, right? Like if you're running a trading agent, if you've ever seen like a high frequency quant firm, those things are nuts. They're just like nonstop trades, right? Solana keeps saying they want to be the internet capital market of the world. Well, they're going to need to be able to handle a lot more throughput, right? Maybe that's where like your ZK compression comes in. You want to be able to have, reputation systems and private information. Again, that's all privacy. And then ultimately, at the end of the day, I think the thing that is probably most short term is just purely the financial payment side, right? The thing that most people tend to come back to, which is really interesting, is they care more about the privacy of their money than themselves, right? Like if you're a citizen in this world that has a social security number, your social security number has been leaked like thousands of times and sold to every bad guy in the world. Sorry to tell you. Nothing you can really do about it. So like most people don't care about giving their social security number away. But again, they don't want to give their bank accounts away, their bank statements, right? That's where you start to get into this world of we want to be able to hide and protect our financial privacy, right? If I'm giving my agent $10, I don't need the whole world to see that comes back to an account that has X amount of value in it. And so I think there's a lot of value there. And then, of course, just in the actual actions, right? If you are doing a trading agent and you want your agent to not get just totally wrecked because some person decides to launch a random meme coin and your agent decides that it's a good idea, then it gets rugged because, well, it got front run by some big whale. Sorry, like maybe you should have used, MEV protection like Byte Protocol, right? Maybe you should have gone through some other, ZK VM to make some sort of provable statement that gets executed later. Who knows? But it's definitely kind of where I'm thinking about this broader world of privacy and AI. Is I think almost every action in some way, shape, or form either should be a private action or should be an action that is going to touch private data or confidential data or confidential information. And I think privacy is going to be like the inflection point of when X402 goes from this world of like memes to being used for like just, people plug it into ChatGPT and say, go do stuff for me. And they know that their data is private, their finance, their private, stuff like that.
Yeah. I mean, I fully agree. I'm first off, I'm a big believer that all of the information, the internet, there's private companies, all the people that own my data know more about me than I know about myself. So fully aware of that, but also a big believer that, right, like there's certain things that should remain private, even if we want to use other, better technology. If we want to use blockchain technology, there's things that should remain private and that should always remain private. Not everything, right? Like there's public conversations like what we're having here that, belong out in the public. There's things that, like blockchain is great for the transparency, but there's things that the technology should be utilized for that keeps and remains things private. I have a million different ways that I want to use X402. Some of them are not possible to talk about on this call here. We are up against time. So I want to ask one final question, and we're just going to wrap this up. And each of you gets, I'm going to give you 90 seconds, 60 to 90 seconds to talk about, one prediction. And one prediction. That's not two. That's not like, hey, let me say one thing and then I'm going to rope in a second thing on top of it. You get one prediction for how privacy and agentic systems will intersect in the next few years. So I am going to start with, let's go back and forth with Gaylord. You're up first.
Okay, so as we said, AI is going to be everywhere. With X402, we have a way to do like micropayments, very regularly, assuming we have the blockchain infrastructure to support that. So now, what's the use case? I need a use case where I need to do micropayments. So I want to be a bit more concrete than the high frequency trading that you mentioned, Sawyer, earlier. So maybe, I don't know, I feel like someone might disrupt some industry. I don't know if it's Netflix, transportation or something, where you would actually pay exactly for what you get. And you would be like, okay, let's say you watch a movie, and to your point, Ben, maybe you need to prove that you're over, I don't know, 18 or 21, but you would only pay for every minute that you watch. And, every minute you would have a payment going on chain. And in the back, you would have, I don't know, an AI verifying that you're in front of that, or maybe they would go buy something for you if they noticed you have like some interest in something appearing in the video. Well, I'm kind of making this up. It's coming up out of my ass, but something I feel like that's going to be something that does not exist right now, and where micropayments are actually going to be at the core of the product. And yes, micropayments will be, of course, going on chain, using AI making the payment for us, basically. Even if it's like 10 cents every second, that's going to be something we don't even realize. But that's optimized for our personal use case, because again, AI are going to be super personalized. Went a bit in all direction, but it was a tricky exercise. So I hope you liked it anyway.
I like it. 3 years is a long time. I would say I think at the rate things are going, I mean, I think it's far fetched. I don't know if it'll happen in 3 years, but I think the world is going to start to look really, really different. I think it already does compared to where we were just honestly like 6-12 months ago. It's a very different world. And I think for me, I do think at some point, we're going to get to, I think we'll kind of probably start with, if you've ever seen it, there's this video game called Cyberpunk. Where like, it's like Elon Musk's like Neuralink thing. Like they've got like all this stuff injected on them. I think like society's heading in that direction. I really do believe at some point our world is kind of going to look like Star Wars, Star Trek. You're just going to have like robots flying around and like all this. And I think the reason I go like that far-fetched is because I think all of that runs on autonomous technology. And it runs on this ability to just like do things, right? Like I'm walking into the movie theater. I don't have to buy a ticket. If there's a seat open, I just sit down, I start watching the movie, and it just like the cents just start flying out of my head, right? The longer I watch the movie, the more I pay, right? It's like, I do think that is ultimately where the world goes, because in a capitalistic society, subscriptions are great for growth. But if you actually want to make the most money, you nickel and dime, right? You take a penny everywhere you can. And the publicly traded companies that start doing that are going to make so much money, because people are willing to pay that one-off use when they won't pay for a subscription. And so I think that's going to like hockey stick growth curve us into just a totally different world that we don't recognize.
And we've seen that, right, in the video game industry, right, with micropayments, right? All video games used to be something you paid, $40 or $50 for, and then you owned the game, and that was it. And then all of a sudden, video games became free, and it became something that you pay 99 cents to speed up, or $1 here, or 50 cents here, and the next thing you know, the revenue that's being generated by these mindless, time sucks on your phone are bringing in millions of dollars in revenue every single day. So if that's a sign of things to come, I think that's, where things are headed with everything else, right? It's just, how are they able to process that? How are they able to do that? And perhaps we have the technology now to actually be able to implement this on scale, with scale, not with scale, maybe with scale, but also at scale. So I'll let everybody interpret that, whether that's with a C or a K. Great branding done by us over here. I am going to wrap things up. I think we've had a great episode today. Gaylord, thank you for joining us. Sawyer, as always, thank you. I learned a ton. I actually know how Z-Take technology works. I know how Byte fits into things. I've learned about FHEs, Ts, ZK proofs, Byte. I've learned how everybody approaches privacy from different angles. Lots of different interesting use cases that, ideally we're going to see develop over the next, I'd say years to come. But really, right, things move so fast. This could be a week away. This could be a month away. That's the space we live in. That's the world we live in. And couldn't be a better time to be alive. So with that, we are wrapping up episode 4 of SKALE School. AI agents and confidential computing. Please give Sawyer a follow. Please give Gaylord and Maiden a follow, and we will see you back here next week. Thanks, everyone.
Thank you, guys.
Thanks, guys.